Ever wondered how a single strand of glass, thinner than a human hair, can carry the entire internet? It's not magic. It's physics, and it's happening right now, connecting you to this video. This tiny thread is a fiber optic cable, the backbone of our digital world. So how does it pull off this incredible feat? Stick around, because we're about to decode the science behind the speed of light. At its core, a fiber optic cable is a conduit for light. But how can light, something we usually think of as just illumination, carry complex data like this very video, with all its colors, sounds, and motion? It all comes down to a simple binary system. Think of it like a superfast Morse code. By turning a laser on and off at an incredible speed, we can create a stream of light pulses. A pulse of light can represent a 1, and the absence of a pulse can represent a 0. These ones and zeros are the fundamental language of all digital information. Billions of these light pulses race through the fiber every second, transmitting massive amounts of data almost instantaneously. But wait, if the cable is just a thin strand of glass, why doesn't the light just leak out? This is where a brilliant principle of physics called total internal reflection comes into play. A fiber optic cable isn't just a single piece of glass. It has two main parts, an inner core, made of ultra-pure silica glass where the light travels, and an outer layer called the cladding. The cladding is also made of glass, but it's engineered to have a slightly different optical property, a lower refractive index, than the core. When the light pulse enters the core at a specific shallow angle, it hits the boundary between the core and the cladding. Instead of escaping, the light is perfectly reflected back into the core, as if it's bouncing off a mirror. This process happens over and over again, with the light zigzagging its way down the length of the fiber, losing almost no energy along the way. This is why fiber optic signals can travel for hundreds of kilometers without needing a significant boost. It's like a perfectly contained highway for light. Now, not all fiber optic cables are the same. They generally fall into two categories: multimode and single mode. Multimode fiber has a larger core diameter. This allows multiple rays, or modes, of light to travel down the fiber simultaneously, each bouncing along at slightly different angles. It's great for shorter distances, like within a building or across a campus, because it's cheaper to implement. However, because the different light paths have slightly different lengths, the signal can get a bit distorted over long distances. This is where single-mode fiber shines. It has an incredibly narrow core, so narrow that it only allows a single, direct path for light to travel straight through without bouncing off the sides, much at all. This eliminates the distortion issue and allows for much higher bandwidth and significantly longer distances, making it the champion for long-haul networks that cross countries and oceans. It's the reason you can have a crystal-clear video call with someone on the other side of the planet. Another huge advantage of fiber is its immunity to electromagnetic interference, or EMI. Traditional copper cables, like the ones used for your old phone line or Ethernet, can be affected by signals from nearby power lines, motors, or even other electrical noise. This interference can corrupt the data, slowing down your connection. Fiber optics, on the other hand, transmit data using light, not electricity. Light is immune to EMI, which means the signal stays clean, clear, and stable, regardless of its electrical surroundings. This makes fiber incredibly reliable. So we have a reliable, super-fast cable. How can we make it even faster? The answer is a technique called Wavelength Division Multiplexing, or WDM. Think of it like this. Visible light is made up of a spectrum of different colors, from red to violet. Each color is just a different wavelength of light. WDM technology allows us to send multiple data streams down the same single fiber, each using a slightly different color or wavelength of light. It's like having multiple lanes on our light highway, all inside that one tiny strand of glass. This multiplies the data carrying capacity of a fiber exponentially, allowing a single cable to handle the traffic of entire cities. This incredible capacity is what makes fiber so future-proof. The cables being laid in the ground today have a potential bandwidth that is vastly greater than what we currently use. As our demand for data grows with things like 8K streaming, virtual reality, and the Internet of Things, We don't need to dig up the streets and lay new cables. We can simply upgrade the equipment at either end of the fiber to use more advanced multiplexing techniques. The highway is already built. We just need to put faster cars on it. So, the next time you're streaming a movie or video chatting with a friend, remember the incredible journey that data is taking. It's a dance of light pulses, guided by total internal reflection through a glass thread, multiplied into countless colors, all to connect you to the digital world in the blink of an eye. Are you ready to continue your journey into the world of technology and knowledge? Don't just watch from the sidelines. Become part of our community of explorers. Hit that subscribe button and join Raahi online, where your path to discovery begins. Let's explore the future together. Thanks for watching.